Okay students, now today we will study how to find out the equivalent resistance for the resistors in parallel. You can see this above figure, there are three resistors R1, R2 and R3 which are connected in parallel, and there is a voltmeter connected across them. All the three resistors will have a common voltmeter connected in parallel, because in parallel connection we have studied that the voltage remains the same. Now there is an ammeter connected in series. Now here we can see that the total current flowing is I, but when it comes to the point A, you see that the current is going to now be divided. Some current will flow through R1, some will flow through R2 and some will flow through R3. So let I1 flow through R1, I2 be the current flowing through R2 and I3 be the current flowing through R3. Okay. So I will be equal to I1 plus I2 plus I3. That is the total current flowing. Now further we will apply Ohm's law to this. Okay, now when we apply the Ohm's law to this, you know Ohm's law is V is equal to IR. So I1 will be equal to what? V upon R1, I2 will be V upon R2 and I3 will be V upon R3. And when we add all the three equations on the LHS, we get I1 plus I2 plus I3. That will be equal to V upon R1 plus V upon R2 plus V upon R3. But what is I1 plus I2 plus I3? That is I. So I is equal to V into bracket. Now take V common. So you get 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now suppose we represent the equivalent resistance as Rp. For series we mentioned it as Rs. So for parallel we will write Rp. Then according to Ohm's law, I, that is the total current flowing, will be equal to V, that is the total voltage difference, potential difference upon Rp. So putting this over there, instead of I we will write V upon Rp, and that will be equal to V into bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now we will cancel V throughout. So we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is your equation for finding out the equivalent resistance in parallel. If there are more resistors, just you have to go on adding. Plus 1 upon R4 plus 1 upon R5 so on till plus 1 upon Rn. So this is how you are going to find the equivalent resistance in parallel. When we solve the numericals, it will become more clear.